All right, so let's look at a different kind of Hume-Rothery rules example now. So in this case, we want to show that two metals will form what we call complete solid solution. That is, they fully meet the requirements of the Hume-Rothery rules. So I'll give you the same data set and see if you can show that these two metals, copper and nickel, will form a complete solid solution. So again, this is going to be in the quiz, so go do that, see if you can work that example, and then come back and we'll work on it together. All right, so in this example, it's not a relative. We want to show that these two metals fully meet the requirements set by the Hume-Rothery rules. So not relative. We want to show that it meets all those criteria. So the first one, as we're aware now, is the relative difference in radii. And so we want to calculate that difference. And so from the tables, I've got the radius of copper, the radius of nickel, I believe. Yes. Copper and nickel. And then we need to reference it to one of the values. So here I chose as a reference point copper. And so that gives us the percent difference in radii. And so if we calculate this, we see that the difference in radii is 2.5%. So even if we chose to reference it to nickel, it would still meet that. You might just get a slightly different value here. And so it checks that requirement. So now let's look at structure. So both copper and nickel have the FCC structure, so they have the same structure, and so they meet that requirement. So the next one is about similarity in electronegativity, or similarity in the position on the periodic table. So you'll notice that copper and nickel are right next to each other on the periodic table. And if you put that in terms of electronegativity, that's 1.9 to 1.8. So 1.9 for copper, 1.8 for nickel. And so this is the one where they don't give you a specific value for comparison, and so you kind of have to just use your judgment on this one. And so in this case, 0.1 is very close, and then values of electronegativity, but you kind of have to use your own judgment in terms of what is close to meet these requirements. And then lastly, valence. They both have a +2 charge, and so they meet that requirement. So again, this is different than the previous example because this isn't looking at relatively which one's better. This is trying to satisfy all the criteria. And by going through one by one and calculating the percent difference in radius, as well as directly comparing all of these, we're able to see that it matches all of those criteria.